Hello, welcome to a video lesson on linear equations and a single variable and proportions. In this video we're going to learn to solve linear equations, some containing fractions, set up and solve proportions, problem solving like word problems basically using proportions, and to identify if one of these linear equations has no solution or possibly infinitely many solutions. So a linear equation in a single variable is an equation that can be written in this form: ax plus b equals 0, or many of you may know it in another form where we use m here instead of x, mx plus b. So you may be used to the use of m in place of that a. If you've ever seen, looks like y equals mx plus b, which is the way a lot of us have seen linear equations. In that a and b both are a cannot be a real a and b are real numbers, but a can't be 0 because that would lose our x term and then we wouldn't have a line anymore. Solving an equation means to figure out what this x is, to find all the values that x can be that make this equation up here true. And the values for x that do make this true are what we call the solutions, or possibly the roots of the equation. Right. Equivalent equations are two equations that have the same solution set, meaning the same values for x that make both true. So negative 3 times 4 is negative 12, negative 12 plus 12 is 0, and just negative 3 equals obviously negative 3. So equivalent equations just have the same values for the solution sets. One important property of solving these equations is the addition and subtraction. Subtraction is kind of put in here with it. The addition subtraction property of equality, and the multiplication / division is kind of grouped in here with multiplication property of equality. So what these properties say is, if you have an equation, have two things that are equal, then we can add the same thing to both sides and it stays equal. So the important thing here is the equal sign stays true. So if you and I both have the same amount of money in our pocket and we both get $5 more, then we still have the same amount of money in our pocket. And then likewise, multiplication, if two things are equal and we multiply both sides by the same thing, then again the equality is preserved. We're still equal. Alright, this also works if it was a minus c. Alright, if a and b were equal and we subtracted the same thing, then we're still equal. And then also if we divide. So a divided by c and b divided by c. Okay. So all of these things work with addition or subtraction, multiplication or division. You just can't divide by 0. Alright, and then c cannot be 0 when we do this. Technically it's true if it is 0, but typically you would not multiply by 0 when you're solving an equation. Alright, so here's just some of those properties to show you. Very basic types of equations. Alright, if I'm subtracting 3 from some unknown number and I want to figure out what that number is, I could add 3 to both sides. Alright, these things get canceled away and I'm left with just an x over here. And because I added 3 to the 8, I get x equals 11. Now we've got an equivalent equation because we preserved the equality. The equality is true. So this equation and the original equation are equivalent. It's just that this one, we can see exactly what the solution is. So that's the whole idea of using this property to solve the equations. Alright, and this just shows that because it's the addition property, even though we are subtracting, it's still part of the addition property. We subtract 7 from both sides. Again, plus 7 and minus 7 cancel. We're left with just x. And then over here, a negative 15 minus 7 is negative 22. Alright, if you have trouble with negative numbers, just know your calculator can handle this type of solution. So like negative 15 minus 7. And then you don't have to have a nice fancy calculator. You can even use a Google search box and do the same thing. So negative 15 minus 7. Alright, enter, and it spits out 22. So there's a calculator in Google that can even handle this. Most computers have a built-in calculator that can handle operations with negative numbers. And then here you also see the division and multiplication property. Same thing. needing to figure out what x is, it's being multiplied by 6, so I divide away the 6. Okay, we have to do what's called the inverse operation. So whatever's being done to the variable, we have to undo it with the inverse operation. So the inverse of multiplication is division, and the inverse of division then is multiplication. And that gets rid of the thing that's being done to x, because we always want to isolate x. Now, we may have to do in some of these equations, in many of these equations, we may have to do multiple properties to be able to solve the equation. So when we solve these linear equations, the first thing we're going to do is try to remove grouping symbols from each side of the equation. So if we have parentheses, we get rid of those parentheses. And then after we have gotten rid of the parentheses by using the distributive property, we combine the like terms. So x's get combined, y's get combined, constants get combined. And then after we've simplified on each side of the equal sign as much as we can, we get all the variables, things that have the letters, on one side of the equation, everything that doesn't have any letters on the other side of the equation. So there's the equal sign. On one side we're going to have the things that have the letters in them, and the other side we're going to have things that have the numbers. And that's our goal. Letters on one side, numbers on the other. And the letters are the variable terms. Okay, and then we get the variable by itself. So the way this is going to work eventually, once we do step 2, we'll have something like this. So many x's equals a number. So all the variables on one side, the constants are on the other. And we'll get to where we can either divide or multiply to do that last step. Right? And then the fourth step for linear equations is just an optional step just to make sure you're right. And that's where a calculator can come in handy to make sure you've done it correctly. So let's just go through one real quick. Alright, so we got a linear equation. I know this is linear because the variables are being raised to the first power everywhere. And the first thing I want to do is get rid of the parentheses. So to do that, I'm going to use the distributive property, meaning I'm going to multiply the 2 times the x, and then the 2 times the negative 4, so 2x minus 8. And then I'm going to combine like terms. So I've got a 2x and a negative 5x. When I combine those together, that's negative 3x, just 2 minus 5, negative 3. And then there's this negative 8 beside it. And then on the other side, that's equal to negative 5. Okay, now everything's simplified on each side. I can't do anything more on either side. So now I'm ready to go to step 2. All the variables on one side, the constants to the other. There are no variables on the right side, so the variables are on the left. So that means I'm going to add an 8 to both sides to get the constants off of that side with the x. So down here you see it minus 8 plus 8, they cancel. But on the right side, because I added 8 to the left, I have to add 8 to the right to keep the equal sign true. And I get a positive 3 from combining these two. So finally, like I said, after we get step 2 done, we should always have something that looks like this. Something times x, or maybe x divided by something, just equals a number, because we've collected the variables to one side and the constants to the other. And so now we're ready to do the last step, which is to divide the number away. So if you notice here, and I'm sorry, I should have a divide by negative 3 here. That should be a negative 3 that we're dividing by. So a negative 3 divided by negative 3 leaves me with just the x, and a positive 3 divided by negative 3. Positive divided by negative is a negative. I get a 1. Alright, and then the checking, you can just plug in everywhere you see an x. You replace it with what you got for x. So I'll replace that with a negative 1. I replace that x with a negative 1. And then I just simplify, and I see that I get a true statement. Remember, that's what it means to be a solution. It makes, when you plug it in for x, it makes a true statement. Alright, now some of the things that we're going to do in this homework set, now in this first quiz, are word problems, applications with linear modeling. So we have a straight line here, meaning that from one point in time or to another, or from one input to another, we just have a straight line connecting the outputs. So we have what we call a high humor group, low humor group. These are how people deal with depression. So the intensity of a negative life event, something minor happened, and this was their how they felt, their depression level basically, and then this was something extremely intense happening, and this was the way they felt. So they have themselves in two groups, and this is the response. So the high humor group dealt with the tragic life event much better as far as depression goes than the low humor group, which is to be expected. But here are the linear models. If I connect those 2 points with a straight line, the line that connects those 2 points would be this 1/9. This one right here, 10/9 plus 53/9 is the low humor group, and the high humor group is this much less steep line, the 1/9 x plus 26/9. So those are the two lines that we're dealing with. All right, what we want to know is, what is the intensity of a negative life event? What is the x value, basically, if the depression response is 7.5 for the high humor group? So this is our high humor group right here. So we're asking if the depression response is 7.5. If we're right here, here's 6, 7.5. What would the intensity of the negative life event have to be to output something that high? So this is the equation we're dealing with the high humor group. So that's where we're going to start with. So d equals 1/9 x, or plus 26/9. And the level of depression is 7.5. So that's the d part here. So we're going to replace d with 7/2, and we're going to solve that thing for x. All right, now the very first thing you want to do when you have fractions in a linear equation like this is to get rid of the fractions. I don't want any fractions in here. So I want to get rid of all the fractions. And to do that, we need to multiply by the least common denominator. So what is the least common denominator for 7/2, 1/9, and 26/9? Well, the least common denominator is the smallest number that 2 and 9 will both divide. All right, and since 2 and 9 don't have any common factors other than 1, then the least common denominator is the product of the two. So the product of 2 and 9 is 18. So what we're going to do is we're going to multiply through this entire equation by 18. So 18 times 7/2, and then the entire right-hand side, because there's a plus sign in there, I'm going to have to distribute the 18 through. I'm going to multiply 18 times both of these numbers. Now, if you have a calculator, especially if you have a nice scientific calculator that can handle fractions, you can multiply that directly. So 18 times 7/2 is 63, and then on the right hand side, 18 times 1/9, you can just type it in directly like that, and 18 times 26/9. Right. So that's going to be my new equation. 63 on the left, instead of 1/9 x, I'm going to have 2x, and then instead of 26/9, I'm going to replace that with a 52. Alright, and now I'm ready to combine all of this, all of the variables to one side, constants on the other. I have a constant on the right, left, I have a variable and a constant on the right, so if I just get rid of the 52 from both sides, I'll be able to eliminate the constant on the right and just have variable on one side, constant on the other. Okay, so I'm going to have a 2x on one side, and then these will combine to just an 11 on the other. So 11 equals 2x, and then I don't want 2x's, I want 1x, so I'm going to divide away the 2 from both sides, and there will be my solution. X is equal to 11/2, or that's the same thing as 5.5. Alright, again, last step, check your answer, see if it's right. So again, if you don't have a scientific calculator, you can use the Google calculator. Okay, so we got 11/2 or 5.5 is our answer. So I would need to type it back in right there where that x is. So I would type in 1/9 oops, let me move that over. 1/9 times x, all right, and we got 5 1/2 or 11 halves. So 11 halves, and then plus 26 ninths. So plus 26 ninths, and then equals, and I got 3 1/2. 3 1/2 is the same thing as 7 halves. All right, 7 divided by 2 is also 3 halves. Okay. There's another great website, Wolfram Alpha, that you can use to check your work. All right, and do only use it to check your work. Don't use it to do your work, because Wolfram Alpha can virtually do any math problem. But I don't recommend you just using it to do your homework for you, because you will have to show work on your final exam. In your final exam, you will have to turn in your scratch work, so make sure you know how to do it. Alright, but if with Wolfram Alpha, I can literally type in again 1/9 times, again I got 11 halves is my answer. 1/9 times 11 halves plus 26 ninths. Alright, if I hit enter, it'll do its thing. And there's our number, 7 1/2. It'll give you a decimal approximation. Alright, but there's our answer in the fractional form. Okay, so we did end up with the 7 halves that we wanted to end up with. So that shows it does work. Alright, not every single equation has a solution. So if we start off with this problem here, what's the steps tell us to do? Well, it says first distribute 2x through. If I distribute the 2 through, if I get that, I'll get a 2x plus 8 for my first step. And notice I've got a 2x and a 2x on each side of the equation. So now when I go to combine my terms and I subtract the 2x from each side, I'm going to cancel out the 2x on the left, but I'm also going to cancel out 2x on the right. And what does that leave us with? That leaves us with the mathematical statement that 6 is equal to 8. Well, 6 is not equal to 8. Now remember, when we do all this stuff to the same side of both equations, we keep this equal sign true. Right? Well, that means that this original and this are equivalent equations. This equation is not true. So what does that mean? That means that this equation up here can also never be true. So the original equation is equivalent to 6 equals 8, which is not a true equation. So that means that this equation that we started off with has no solution. Or we can say the solution set is the empty set, meaning that there's the same way of saying there is not a solution to this thing. Now let me show you what this looks like graphically. So a graphing calculator can graph these things. I'm going to clear this out, turn that off, and I'm going to type in each one of these sides of the equation and in each one of these y equals on my screen. So the first one, I'm going to graph 2x plus 6. And then the second one, I'm going to graph the right-hand side of the equation, which is 2 times parentheses x plus 4. And when I graph this, there's the left side of the equation, and there's the right side of the equation. Now, when there is a solution, when we do get a solution, it's the intersection of these two lines. Like, for instance, this equation that we solved earlier, the solution was x equals -1. If I graphed it, there's the left-hand side of the equation. This whole left-hand side is this line right here, and then -5 is just this horizontal line. There's no x, so it doesn't change. But their intersection, the x-coordinate of the intersection is -1. And that's what we're doing here visually, graphically, is if we graphed the left and right-hand sides, we're finding where they cross. Well, if an equation doesn't have a solution, like we saw with this one, then that just means the two lines just don't cross. Alright, and then likewise, if you're solving an equation, and notice again, when I solve this equation, I distribute the 6x through, I get 6x plus 6, and then when I combine my like terms, 6x minus 2x is 4x. Alright, well notice on the left-hand side, the whole time we've had 4x plus 6, and now on the right-hand side, we also have 4x plus 6. So because the left and right are now the exact same thing, anything I plug in for x is going to work. Okay? If I were to subtract 4x from both sides, if I were to go through and try to do the procedure we've been talking about, I'm going to lose all my variables, and I'll have the statement 6 equals 6, which is always true. So no matter what I plug into the original equation, it would work. Okay, and this graphically happens when the left-hand side and the right-hand side end up being the exact same line. And again, you can obviously see it right here. These are the two exact same lines. So when I graph them, they are going to look identical, meaning one will look like this, and the other one would go in right on top of it. And every single point, they're intersecting. So all x's are solutions because every point on there is a point of intersection. So that's the two rare things that can happen. You can have no solution. You can have infinitely many solutions. But typically what happens is you just get a single solution. And when that happens, the solution is the x coordinate of where they intersect.